This video explains what feed, or front-end engineering design, really means and why it plays such a crucial role in the success of industrial projects. FEED stands for Front-End Engineering Design. Simply put, it is the bridge between concept and execution. At this stage, the project scope, cost, and technical requirements are defined, turning an initial idea into a detailed plan. The main objectives of FEED are fourfold, and each one is critical to project success. First, defining the project scope. At this stage, the project is clearly outlined and what it will deliver, the process units, the capacities, the technology to be used, and the boundaries of work. This removes ambiguity and ensures that everyone, from client to contractor, shares the same understanding. Second, creating accurate cost estimates. Unlike preliminary estimates, FEED provides a much sharper view of capital investment, often within plus or minus 15 to 20%. This allows management to take confident investment decisions and avoid financial surprises later. Third, ensuring compliance with safety and regulatory standards. FEED is the stage where safety reviews and environmental considerations are built into the design itself. This means fewer modifications during construction and smoother approvals from regulatory bodies. Finally, planning a realistic schedule. By carefully sequencing engineering, procurement, and construction activities, FEED sets achievable timelines. This helps align contractors, suppliers, and project teams right from the beginning. Together, these objectives make FEED much more than a design exercise. It is the foundation that guides the entire project, technically, financially, and operationally. The heart of FEED lies in its activities, a series of technical and planning tasks that give the project a solid foundation. First, process flow diagrams, or PFDs, are developed, which capture the overall material and energy balances. These diagrams ensure that every input, output, and interconnection in the process is well understood. Next, piping and instrumentation diagrams, or P&IDs, are taken up. These are the blueprints of process control and safety, showing valves, instruments, alarms, and interlocks. They help anticipate how the plant will behave in real operating conditions. Parallelly, detailed equipment lists and specifications are prepared. This includes defining equipment sizes, construction materials, and utility requirements for items like reactors, heat exchangers, distillation columns, and pumps. Once the process and equipment are defined, attention shifts to plot plans and plant layouts. Here, we determine where equipment should be located, ensuring safety clearances, smooth material handling, and easy access for maintenance. Another vital part of FEED is assessing utility and infrastructure needs: electricity, water, steam, compressed air, effluent treatment, and storage facilities. Without accurate utility planning, even the best design process cannot run efficiently. In parallel, HSE and compliance studies are conducted. These cover hazard identification, risk assessment, and environmental impact evaluations. It is ensured that the design meets both local regulations and international best practices. Finally, one of the most important deliverables of FEED is cost estimation and project scheduling. At this stage, cost accuracy improves significantly, typically within plus or minus 15 to 20%. This allows clients to make informed investment decisions. Based on this, tender packages are prepared for critical equipment and services. Having these ready early helps avoid delays in procurement and sets the stage for smooth project execution. Together, these FEED activities build the roadmap for the project, transforming a concept into a well-structured, costed, and risk-assessed plan ready for detailed engineering and execution. Why FEED truly matters? What often happens when projects move forward without proper FEED? Designs are incomplete, errors show up late, contractors face confusion, and the result is delays, cost overruns, and safety risks. Now, when the project with a robust FEED is in place, the design is validated, virtual plant is ready, costs are estimated accurately, and all stakeholders have clarity from the very beginning. Construction proceeds smoothly, timelines are maintained, and the plant is delivered safely and within budget. This is the power of feed. It reduces uncertainty, saves time and money, and ensures that projects are executed exactly as envisioned. A small investment in feed creates immense value in the long run. Successful front-end engineering and design needs expertise, technical soundness, accuracy, cost-effectiveness, and adherence to global standards. In short, feed is the foundation of every successful project. A strong feed ensures reliable execution, cost control, and long-term success, guiding projects seamlessly from concept to commissioning.